when you start looking at the body and individual differences, you'd be amazed at how different we are, or you may be, from that generalized plan that we teach to any kind of anatomy 101 type course.
Welcome to the Wits and Weights podcast. I'm your host, Philip Pape, and this twice-a-week podcast is dedicated to helping you achieve physical self-mastery by getting stronger, optimizing your nutrition, and upgrading your body composition. We'll uncover science-backed strategies for movement, metabolism, muscle, and mindset with a skeptical eye on the fitness industry so you can look and feel your absolute best. Let's dive right in. Wits and Weights community, welcome to another episode of the Wits and Weights podcast. Today, I'm excited to welcome Justin Cottle, former lab director at the Institute of Human Anatomy. He's a pioneer in using real human cadavers to educate the public about the human body. Justin is also a content creator and writer at The Dissection Room, which is a very cool Substack and YouTube channel devoted to dissecting life, creativity, lots and lots of different topics that go even well beyond just health and fitness and the very idea of what it means to be human. I invited Justin to share how understanding our digestive system's anatomy can lead to better nutrient absorption, overall health, and then also how our bodies physically adapt to training. So we're going to try to cover both of those topics today. We're going to explore how to use anatomical knowledge for personal health and fitness strategies so you can optimize all of these things. And I find that Justin has this very unique, curious angle on human anatomy. It's why I wanted to bring him on. Combines the practical application with the science to empower you to make informed health decisions and reshape how we think about our bodies and our capabilities. Justin, it is pretty cool to have you on the show.
Thank you, Philip. That was quite the introduction, and I'm happy to be here.
Awesome. Yeah. So let's get into the background of how you came to work with, human anatomy, specifically by way of cadaver research. It's funny, when I was coming up with titles for the episode, and actually I was using AI because I do like to do that to brainstorm. And it's like all this stuff about corpses and beyond the grave and everything. I'm like, no, we're not going to go all macabre here, but I do want to understand how we can link, that kind of information to practical decisions that we make. Tell us how that started to click for you. Like, where did you make that connection? And then did you start to communicate that in an understandable way?
No, so anatomy is, I'm fond of saying that anatomy is the baseline science. It's this, there's a reason why no matter what kind of health program you're taking, anatomy in some capacity is at its core. And that was the same for me when I started out. But I fell in love with anatomy. As soon as I took my very first anatomy class, it was really unintentional. I never really, I wasn't growing up thinking, oh, I'm going to work with, body donors and cadavers. That was never a thought. It just kind of ended up being that way when I took my first anatomy class and realizing the power of human anatomy, not just in obviously explaining everything within health and fitness, but also just the mindset. I liken it a lot to almost like a watchmaker, where you have to, when you know the parts that everything's built of, it is really easy to understand all these other things that are branching off of it. And I realized that very early on and just fell head over heels for anatomy. And one thing led to another, and I ended up working in a cadaver lab. And that in itself is a completely different, it's hard to say this properly, because a lot of people who take anatomy classes don't work in cadaver labs. You may have a cadaver lab, but to actually work in one is a different thing. And so when all of a sudden I found myself having that opportunity to work with the actual body donors, that just fueled the passion even more, because then all of a sudden it's not just looking at a textbook, looking at an anatomy atlas, it's holding the organs, it's performing the dissections yourself. And it's just an exciting thing that just out of nowhere, I found myself having been doing it for 10 years. Again, all of it completely unintentional, but extremely exciting nonetheless.
I love your analogy of the watchmaker and really understanding what's underneath each layer, because I have that same sense of, if I don't get where it's coming from or how the connections are made, I don't just want to trust what you're telling me, when I break it apart. A couple of things come to mind is, first is art. Like Leonardo da Vinci is well known for using human cadavers to understand anatomy and then translate that to how humans move and are portrayed in their strength and movement on the page. And I'm sure that you've gotten into some of that. I also, just a few minutes ago, both my daughters, we homeschool our daughters, and they outline themselves on a big piece of paper. And they drew a bunch of the major bones, and they're going to add layers to that And I told them about you, that I was going to be talking to you in a few minutes, and just them trying to understand again from deep down where all this comes from, because there's a lot of misinformation out there. There's a lot of experts telling you what to do. And here you are, a guy that's, coming from the science of it all. So yeah, it's pretty cool. I don't have a question there, Justin. I just think it resonates.
That is really cool. I do want to say, my hat's off to you for homeschooling your children. That is so cool. And it's something I'm really interested in myself, is actually developing anatomy programs and curricula for homeschoolers. So we may have to talk about that
awesome.
in a different time, because that is something I'm very interested in these days. But hats off to you.
Cool. Absolutely. And I think of like my wife, I'm going to give her most of the credit for the day-to-day, because she actually runs our school and teaches them. But one of the things with homeschoolers, and this is relevant, is at least there's a misconception that you have to be an expert to teach anything. Like you have to be an expert teacher with a certification to do this. And it's just not the case. I think if you have the passion and want to learn something, the best thing for kids is to learn how to learn. It's not to be data dumped information. It's to learn how to learn. And I see my kids now, getting beyond my wife and me, our knowledge, they're surpassing that at the age of 10 to 12 in many cases, and they're able to do that. So we try to do that on this podcast too, is just like educate people and teach them how to find the information. So you have a great source of that. And for people, we're going to plug his stuff a few times here, but it's the Dissection Room YouTube channel. All right, cool, man. So one of the topics we wanted to talk about, because you said you had a personal connection to this, was gut health, or I should say digestive health, nutrient absorption, and hopefully we can segue from that into what that means for how we eat and how it helps us perform. But just tell us, I guess, maybe we start with anatomy or your story. We can go either way, like start with the anatomy of the digestive system and the function and like how this is all relevant to us. Why do we care about this?
Yeah. So I think I can real quickly tell the story of why it's so relevant to me, is in that in 2018, I found myself randomly having a small bowel obstruction, which is where my small intestine, which is the nutrient absorbing aspect of the GI tract, just essentially got blocked. And this normally happens to people in their 60s, 70s who have history of abdominal surgeries, and I didn't have any of that. And I got very close to actually passing away, went into kidney failure, and this all happened within just a couple days. I was 30 years old. Really healthy. I'm ex-military. Like I take care of my body, and this just hit me. And I obviously ended up being okay. But what it did is it just fueled, which I was already obviously knowledgeable on the digestive system, but then all of a sudden it became more relatable. It became more, important to me and personal. And so it just kind of has started this, what has never really stopped, this passionate investigation into the nuances of the digestive system. And so with that, when we're talking about the digestive system, it's really, you have to understand that it's the first thing to develop inside of the body. So before you have a brain, before you have a heart, the actual developing embryo has a gut tube. And that's what anatomists actually call it. And so it invaginates in, and invagination is just a tunneling inwards, where all of a sudden you look at this tadpole looking creature, and this tunnel forms from the mouth, which really isn't the mouth at this point, all the way down towards the rectum. And everything about your body builds around that. And so it's the axis of development. And when you think about it, that means, your mouth, your lips is just one hollow tube. If you could actually stick your hand through your mouth and go down the entire digestive tract, you're inside your body, but technically you're outside your body because it's one hollow tube from point A to point B. But everything happens there. We're talking chemical and mechanical digestion, nutrient absorption, excretion through waste. It's amazing, as someone who has had an actual, like, real severe digestive issue, it's incredible to understand just how important it is. If things go wrong with your digestive system, immediately. I'm not trying to, turn this into like a contest of which is worse, but it's like with cancers or other types of dysfunctions and diseases, they can be more subtle, but not digestive issues. Digestive issues, they hit you, and they hit you fast, and very quickly that something is wrong. And I think that's something a lot of people understand intuitively, especially with poor diet, because it doesn't have to be a small bowel obstruction for you to understand that something is wrong with it. But I'll finish it up real quick right here. So if we're talking the straight up anatomy, You have your mouth, your oral cavity that goes down to your esophagus, that goes down to your stomach, that then transitions into the small intestine. So the stomach is what kind of turns it into like this soup called chyme. It's just a nutrient soup, and then releases it into your small intestines. Those are about 30 feet long, depending. It could be anywhere. It could be as low as 15 feet. And that's where all the nutrients are absorbed. And then anything that isn't absorbed drops into the large intestine. And that's what also people will call the colon. There is a little bit of a difference, but it's not that important. And then that's where you just kind of absorb waters and salts. And then that will obviously then be defecated out as waste. So it starts in the mouth and it ends at the anus.
Yeah, I think that's awesome. I love this stuff. I can geek out on this stuff. I love the idea of the tube being both inside and outside the body. And you've already talked about the different processes at different stages, the chyme, and I guess there's bile at in fact, saliva at the beginning, right? And then all the different fluids. Again, thinking about my daughter's talking about this stuff recently, and it's like, we don't talk about it at the dinner table, but we'll talk about it. How do like enzymes and hormones come into all of that facilitation of the breakdown? Because then I imagine that's going to lead us to talking about how we utilize nutrients from what we eat and then utilize those, because I want to segue into that. But just real quickly, is there anything else we need to understand mechanistically, hormones or enzymes or anything?
Well, so when it comes to the enzymes specifically, the enzymes is just something that is basically causing an action to occur on a molecule. So you have like proteases, lipases. So anything that ends with ase is an enzyme. So a protease would break down proteins. A lipase would break down lipids. So you're going to have some enzymes that are actually inserted into the digestive tract at the stomach, but most of them happen in the very, what we would say in anatomy, proximal end of the small intestine. So that's the very beginning. So as soon as your stomach releases the contents into the small intestine, that's where the liver and that's where the pancreas start just dropping enzymes into the actual small intestine. And for one, it helps neutralize the stomach acidity. This is something that not a lot of people think about. Stomach acid, hydrochloric acid, it could eat your small intestines. It could literally digest it. So you have to have a way to neutralize it. So as soon as your stomach empties into the small intestine, it's met with a neutralizing agent and it neutralizes the stomach acidity. But you're also going to have enzymes that are being inserted into there to help break down carbs, lipids, and proteins. And that will continue all the way down into the large intestine. But at the same time, once they get absorbed and then they go to the liver is what actually, I like to think of it almost like a bouncer at a club, where if you're on the list, it lets you through. If you're not on the list, it's a hardcore club, and instead it would destroy you. So easiest way I can describe this to people is like alcohol. The real easy example, when alcohol gets to the liver has various enzymes that will actually neutralize it, but you can overwhelm it, and then that can go into the bloodstream, and then obviously that can cause repercussions elsewhere. Point here is hormones don't really become affected until something passes the liver and gets into the bloodstream, and then that's when it goes global. And that's where you're going to get many different hormonal responses based on the specific nutrient and just things in the composition of the blood.
Cool. All right. So then that clarifies maybe two subtopics from this that we can cover. One is the utilization of nutrients. You mentioned macros, but even micros, and then how that then downstream affects performance, building muscle, whatever. I mean, the listener of the show is very much into body composition and strength training and lifting and eating protein and all that fun stuff, carbs and whatever. So the effects of those, and then since you mentioned hormones, we can talk about the downstream effects on things like your thyroid, which is a hot topic these days, especially for peri and postmenopausal women worried about thyroid conditions and like, do I eat all the right foods with the right nutrients to do that? So yeah, let's start with the nutrient absorption piece of it.
Sure. So to be clear, when you're talking about the nutrient absorption, what specifically do you want to talk about?
Macros and micros. Let's start there.
Okay. So it really just kind of depends on, I guess you can put it this way. So once everything gets boiled down into your stomach will rip it apart. And then that's where you have that chyme is a macro soup, essentially. But once it gets into the small intestine, there are these little appendages called villi. And villi, this is really wild, have even like smaller little microvilli on them. And that's where all the capillaries are. And the capillaries are what are going to absorb all the nutrients. And you want to get that typically as small as you possibly can, because if something is too big, then it can't be absorbed. And so that's what the job is of the hydrochloric acid in the stomach, as well as the enzymes coming from the liver, the gallbladder, and the pancreas. So you'll have this micro and macronutrient soup that is flowing through, and then it gets absorbed into the bloodstream. Once it gets into the bloodstream and goes to the liver, it really depends on the nutrient itself. It depends on a whole cascade of signals. The pancreas, for instance, the pancreas has blood flowing through it that is actually sampling your blood sugar levels. So it's sitting there going, oh, okay, so I have this much sugar, so we need to either drop in insulin and reduce that, or glucagon and increase that. And that's obviously then going to have an impact on all of the adipocytes. Those are the cells that store lipids and your fat. And that is going to have an effect. You're also going to have an effect on inside of the muscle tissue as well, because how much sugar you have is going to be signaling to the muscle itself, oh, do we need to store this in the form of glycogen? So then you can stuff that more full. So it really just kind of depends on the specific area. You almost, to really understand how a micro or a macronutrient is going to be affecting an area, you almost have to say this area, that area, this area. But then you have to start thinking about things like individual circumstances and genetics, individual health, all of those things. But when it comes down to micronutrients are more so like tools, while macronutrients are kind of like energy sources and building blocks. And so like lipids will be typically used to help improve the health of the cell. Actually, here's an easy way to say it. I'm very fond of this. This is one of my favorite sayings. You as a human being are essentially proteins wrapped in fat and fueled with sugar. That's essentially what you are. And so then what your body has to do is figure out which cells need the protein, which cells need the lipids, and which need the sugar. And then obviously there's a whole various amount of metabolic pathways. So it is really that nuance though. You almost have to be like, okay, how does it affect this area? How does it affect that area? And you can even get as nuanced as, and what time did you wake up? How long have you been in a heavily fasted state? How, not only were you working out, was it resistance training or were you doing cardio? There's so many things that can literally impact just how these micro and macro molecules shuttle around the body and the way they actually go into the cells.
Yeah. And this is where I can get into trouble as a nutrition coach, because we want to give people simple, practical things to consider for them without overwhelming them with the why. But I'm so fascinated by the why, and some people want to understand why all this stuff happens. So if you were to step back a level and say for the average human who is active, right, which again, we're talking about folks who are active, maybe their strength training is just a balanced approach and paying attention to how you feel the majority of it here? Or is there some more knobs that you tend to play with when you recommend kind of what and how to eat in terms of your actual diet?
It's such a good question. It's an important question too, because, I am not the type of person who likes to feed into hype, but at the same time, sometimes hype is there for a reason. And there are certain things and there's certain signals that we should be listening to. At the same time, another saying that I'm very fond of saying, and I can't even remember who the physicist was, but there was this theoretical physicist who said, I would never touch nutrition with a 10-foot pole because it's too complicated. And I think that really kind of sums everything up, because nutritional sciences that encompasses it is so difficult to really figure out what's going on. A lot of times people think you can just put in some kind of micromolecule and look at it in the bloodstream and figure out exactly how a cell utilizes it. And unfortunately, that's just not the way it is. And so a lot of times we are in the dark. We can look at things from a more just, circumstantial study type perspective, where it's just like, oh, well, we gave some people some bread and this is what happened. It's more of an observational study. And I know we want better answers than that, but unfortunately, sometimes we just can't get those really nuanced answers that we really want with nutritional science. That's changing, that's getting better, and that's really exciting. But what I typically tell people is it's best to start from a very generalized sense and then start figuring out what works and what's not working for you. And that is something where someone like yourself really comes in handy, because then you can start to titrate that, right? You can start to go, okay, well, we're going to turn this knob here, we're going to turn that knob there. But the knobs that I turn, for me, that I think just make the most sense is to get rid of as much ultra processed foods as you possibly can, to try and eat as many whole foods as you possibly can. For me, I don't drink alcohol. I don't drink coffee. I try to not have any caffeine if possible. That's not to say that you can't. It's just, I personally find myself that works better for me. I try to eat as much fiber as I possibly can. And I try to eat diverse sources of fiber, because diverse sources of fiber are going to be fantastic for your microbiome. But at the same time, it's like my main focus, if you could say, would just be whole foods, drinking lots of water, getting plenty of sleep, trying to get good exercise and take care of my body. They're really general things that are really uncontroversial. But I also think it's something that a lot of people just don't do.
That's the best way that you just put it there. It's not controversial. It's almost boring. It's not sexy. It's what you got to do when people aren't doing it. Oftentimes they're looking for something to optimize when really they just need the big blocks. So yeah, the whole foods, the hydration, limiting toxins of different kinds, and then diversity. So that leads me to, you mentioned the microbiome. Let's answer the hormone question, right? Where someone says, well, I have hypothyroidism, let's say, and I want to address it naturally. Is it just a matter of eating more oysters and Brazil nuts, or like specific foods that have specific nutrient? And it may be, I don't know. How do you approach the topic of hormones in general and linking that to micronutrition as well as the anatomy of the digestive system?
It is so hard to have that conversation without someone doing the proper blood work and actually figuring out what their levels are. So many people, and myself included with a lot of things, this is not to demonize anybody, because at the same time, how available is it? I mean, it's gotten a lot more available. There's a lot of really fantastic testing that people can do, home testing kits, for example. At the same time, though, when you're doing these types of things in reality, to have a good understanding of how your hormones are really being affected, you don't just take one test. You need to take a series of tests. And then you need to be able to compare that data. And that's where things just kind of get difficult, if not outright impractical for people. So it's hard to say will this work or won't this work? But I think generally speaking, yes, oysters is going to be good for you. I mean, I love eating oysters. I love having, just getting as much DHA and, you want to take care of yourself and get the specific fats, proteins, and healthy carbs that you are supposed to be getting. And there are different sources that may be more optimized. I don't know if that's not the right word, but just might be better for you, generally speaking.
Yeah, more nutrient dense, let's say. More bang for your buck, yeah.
That's the way to put it. At the same time, though, it's really hard to say. It really is hard to say. And I know that's one of those, no one likes that person. And I'm being that person who's like, well, it depends.
It depends. Yeah. That's always the answer, though.
But with nutrition, it really does depend. And I think, like you even mentioned, people are always looking for that just give it to me now. Give it to me straight. What do I got to do? And I understand that. I'm very sympathetic with it. But unfortunately, you don't know what you need to do unless you have data. And I'm not saying you need to have some, become have these analytics charts. You don't necessarily need to have, be so robustly into this. But at the same time, if you're just flying in the dark, it's really going to be hit or miss. And so at the end of the day, I think I always encourage people, if they are curious about their hormones and how their body is responding, they need to get tests done. And then from there, you can start to figure out what may need to happen.
Cool. Yeah, that makes sense. And it does get confusing with tests because it's blood work, saliva, urine. What do I get? Who do I go to? Because now you've got insurance and things involved that doesn't always cover all of that. You've got doctors that are sometimes clueless about it. And then there's functional medicine individuals. So you're right. It is a lot of that. It's funny because I have some questionnaires that I can use with clients where I try to tease out some symptoms at least to get started, because that's often a good, starting point. And some of these questionnaires are like 30 questions because it is so complex with, is it your thyroid? Is it testosterone? What is it? So that's good advice. And then you did allude to hype, and I want to get back to that. If you had to pick one thing that is actual hype and one thing that's hyped but real that comes to mind that's like often talked about in the industry, what would they be?
That is such a good question. So, I mean, when it comes to hype, the thing that just naturally, or that doesn't live up to the hype, I guess I should say, the thing that naturally comes to mind are going to be fad diets. I think that's a general answer, but I mean, for instance, the carnivore diet, and here's the interesting thing, especially if we go back to keto. This is me, I guess this is kind of like a humble brag, but I remember being into keto almost 15 years ago. No one knew what keto was. And I was really interested in keto because there's a really interesting researcher named Dom D'Agostino. And Dom is the one who actually worked with the Navy SEALs because the US government was like, hey, the ketogenic diet actually helps minimize seizures. And so they wanted to actually help these special operators not have seizures when they were using rebreathers underwater as they were actually going after the enemy. The whole point here is Dom D'Agostino, I was listening to him and really diving into the research for a ketogenic diet, back in 2010. And no one knew what it was. And I was really interested. But as soon as it became a fad, everything went off the rails, where all of a sudden it's like, there's actually really interesting stuff about keto, but it gets lost so easily. And I find myself, when I'm having a conversation about the ketogenic diet, I almost become anti-keto because I'm having to fight so many things, even though I'm actually a proponent of it under certain circumstances. Same with carnivore diet, elimination diet, specifically when people are just kind of like purging in mass. It's like that may work for certain circumstances, but it just, I think generally speaking, is almost never a long-term solution for anybody in any circumstance. And so I think that's a real easy answer, but I think it's an important answer because it's so easy for people to just jump onto these fad diets, even if they are healthy people. It's not like you need to be losing 30, 40, 50 pounds. It's just more so like, naturally the question, if I'm lifting, maybe I just go carnivore, And at the same time, I think people who've been lifting for long enough understand the importance of carbs and understand why that's probably not a good idea, but you still see those types of ideas out in the masses. So that would be the easy answer, but I still think it's an important one. And then one that lives up to the hype is the microbiome. Easily. The microbiome is probably one of my favorite things to talk about, something I could talk about for hours, and not just in the digestive system, but just all over the body and its importance. But the importance of fiber and diverse sets of fiber, fermentable fiber, non-fermentable fiber, just understanding what these things are, but how beneficial they can be for our health. And a real easy example I can give is this is speculative, but I would not be surprised if many of the metabolic diseases and disorders that we see are really just a problem or an artifact of a bad microbiome, in the sense that people are just been eating such bland foods that what's happened is there's no diversity, there's no resiliency in their gut, and their bacteria are suffering, and it's just having far-reaching repercussions. So the importance of fiber, I think, is something that I'm really excited to see people getting on the microbiome bandwagon. At the same time, I will say this, and I'll be quick. I do think people have gone overboard with it when it comes to prebiotic supplements, probiotic supplements. I think it's easy to start to just turn that into the fad, and that's what we've been seeing. But I still think at its core, it's pretty solid.
Those are two really solid answers. I mean, the fad diets, for sure, we talk about it all the time of, at the end of the day, it's what's sustainable for you. But at the same time, even if a quote unquote fad diet is sustainable from a practical standpoint, are you still missing out in other areas? And that's where I tell people to really take the whole picture into account. Like if you're doing carnivore and all this stuff is great, but something else is not quite there, that could be a red flag of, okay, you're missing some plants. Maybe you should have broccoli. And speaking of broccoli, like when I hear influencers say broccoli's now bad for you because it has goitrogens and it's going to inhibit iodine absorption. And you're like, oh, really? And people get freaked out. And you're like, well, only if you eat like, gobs and gobs of raw broccoli every single day forever, and have a inflamed thyroid at the same time or whatever. So that's a good segue because we are talking about digestive health. You talked about diverse sources of fiber, probably having enough fiber and having enough diversity of food in general. I've also heard, things we can't control as much, but are important are early stage in our life, like from infancy and the type of birth and breastfeeding and like having pets and all of that. What would you say when it comes to gut health and the microbiome are the top few things that people have the most control over as adults? And maybe you already mentioned it with the fiber, but like a couple actions people should take or assess in their lives now that would help that.
So easy things that people can do is when I say diversity, I really mean that in a very simple sense. So for instance, if you can break down fiber into two, there's different ways you can break down fiber, right? Soluble, non-soluble. But my preferred way to break it down is fermentable and non-fermentable. Fermentable fiber is the type of fiber that many species of bacteria in your gut will break down, and then obviously they ferment and you produce gas. So the main sources of fermentable fibers that I like to bring people's attention to are going to be inulin and pectin. Inulin, you find that like in garlic, onions. Pectin, a lot of times you'll find that in the skins of fruit. So like, pears, apples. So when you're talking about diversity, you have different kinds of so just picture yourself in the grocery store. You see like a Gala apple, you see a Fuji apple, right? You see a Red Delicious apple. Those are 3 different sources of pectin. And that can actually impact your microbiome in subtle ways, but still meaningful ways. Meaning try to get around, or at least I try to get around 20 different sources of fermentable fiber in my diet per week. And that can be as simple as just going to the produce section and, you're looking at like yellow squash versus zucchini. Well, that's going to be different. Yes, they're still squash, butternut squash, and trying to get the skins, trying to get the fiber content in there. And you're helping your microbiome because you're giving diverse food sources to those microbiota, so those species. And what that does is it builds up resiliency, because you have to think about it. It's almost like there's a turf war inside of your colon where you have millions of different species and then millions of those species. So there's hundreds of millions, literally maybe 500 million species inside, not species, 500 million bacteria inside of your colon. There's only so much space. If you just eat the same food source over and over, what you're doing is you're only giving food to the species that consume that. And what happens is the ones that don't start to die away. And then the other ones start to take their space. And so even if you start eating more diverse food sources, you may have already killed the bacteria that could have broken it down and benefited from it. And that's why, for me, it's like, I think just having a diverse diet starting as early as possible, right? We're talking, this is where the importance of your fruits and your veggies, giving it to your 3 and 4 year olds, right? Just getting them to understand the benefits, giving them, and, obviously you can cook them. You don't have to give them raw broccoli. No one's going to like that. But finding ways to really turn that into a habit, and just simple ways of going to the grocery store and just going, hey, I haven't had that apple. I haven't had that type of onion. You try those different sources. And if all else fails, you can always go the supplement route. But I think it's a real easy thing that people can do.
That is awesome. I haven't heard it put that way. And I'm like already thinking, I got to go generate a list of all these foods separated by those types. You probably have something like that already or did a video on it, I'm sure. But still, that could be a super helpful resource for folks. Yeah, I didn't even think about like having different types of the same fruit just to get the different pectin in the skins. And speaking of pectin and all types of fiber, we often don't break down things beyond what we see on the nutrition label, right? We see macros and micros, and even not all the micros listed on the label. And there's all these other compounds, these beneficial compounds in the various aspects of the foods, antioxidants, whatever, that you get from the diversity. So I think that's a really good message.
My name is Tony. I'm a strength lifter in my 40s. Thank you to Phil and his Wits and Weights community for helping me learn more about nutrition and how to implement better ideas into my strength training. Phil has a very, very good understanding of macros and chemical compounds and hormones and all that. And he's continuously learning. That's what I like about Phil. He's got a great sense of humor. He's very relaxed, very easy to talk to. One of the greatest things about Phil, in my view, is that he practices what he preaches. He also works out with barbells. He trains heavy, not as heavy as me, but he trains heavy. So if you talk with him about getting in better shape, eating better, he's probably going to give you some good advice. And I would strongly recommend you talk with him, and he'll help you out. Thanks.
So before we move to the second topic, because man, this could be like a 2-hour podcast if at the rate we're going, seriously. What about individual differences in anatomy or even like pathological conditions that affect some of what we're talking about? Is that worth getting bothered about, worth discussing, or is it more of a like, when you have a problem, you deal with it?
So I think like the way I think about it is there is the intellectual side of it, and then there's the practical realist side of it, where intellectually, I think it's a very fascinating conversation, but practically there's not much you can really do about it in terms of, say, like, let's talk about just the individual anatomy aspect. The digestive system can vary. Like I said, the small intestine can be anywhere between 15 and 30 feet long. Now, if you were to look at the data, you might be like, I think Shaquille O'Neal probably would have a longer small intestine, right? He's bigger. But if you look at the data, it doesn't actually always correlate to height, meaning a taller individual might have a smaller length of small intestine and a shorter individual might have a longer small intestine. Why that makes a difference? If you have a longer small intestine, there's more time for nutrients to be absorbed. You get more nutrition from the food you eat. If you have a smaller small intestine, you get less nutrition from it. And that can actually impact your diet. The thing is, how do you figure out how long your small intestine is? Right? There's not really many tests for you to do this, right? You go talk to your GI doc and just be like, hey, would like to measure my small intestine. Well, I mean, they're not really going to be
Yeah.
able to do that for you. And so that's where all of a sudden it goes into that practical realm of, I don't know what to do with it. Obviously, there's going to be, digestive issues. You have celiac disease, you have Crohn's disease, you have immune diseases. So that is more practical. Obviously, you can kind of tackle that. But I think what I personally think is the best response for most diseases of the gastrointestinal tract is still to tackle diet right at the very beginning. And you find it doesn't fix it. I'm not here to say it fixes things, but it does alleviate a lot of problems. And so it's hard. Again, you have to take it on an individual basis, but there are differences in people's anatomy. There are differences that people can measure in some aspects, but usually there's not much you can do about it in a lot of ways. It's hard. It's complicated. You would need to have a considerable amount of money to be able to do a considerable amount of tests in order to figure out the nuances of your own body, or you could let someone dissect you, and that's probably not going to work for you either.
It's interesting. What comes to mind for me is when you talked about it generally starts with diet, which totally agree with that philosophy. Like, let's do things naturally as best possible and then see what's left that we might have to deal with. So I have an esophageal condition called eosinophilic esophagitis. Had it since I was young, where it made it very tough to swallow because I have these little nodules in my esophagus, eosinophils that migrate there. There's some protein that causes them to migrate there. And before there was a medication for it, there's an asthma medication that they labeled, they tested and actually worked on this. And I take it and it works wonders. But before that was the case, I had two options: either take some sort of like beta blocker or something like that, or eliminate dairy, gluten, and like 4 other food, like almost every food I enjoy, right? So what are your thoughts on, like, because that's where there could be a trade-off. I could have done an elimination diet and found it was this one thing, but I'd rather just inject myself and enjoy all those foods, and maybe that's not the right approach. What are your thoughts on those kinds of things?
So this is why I'm so passionate about the microbiome, is because when researchers first found the Hadza are one of the last remaining hunter-gatherers on the planet. They're in Tanzania. When they first stumbled upon them, the children's bellies were bloated, and that is a huge signifier of malnutrition. Well, they weren't malnutritioned. They actually were fermenting. Their guts were so big, they were just so full of gas. And researchers have learned, and this has been on a steady decline because the Hadza are starting to become integrated into modern society, that the Hadza are the healthiest people on the planet. Obviously they die of bloodborne diseases like malaria, but you have Hadza hunters who can literally take raw colon from an antelope and chew on it. And they can scoop out the contents of an antelope's stomach and put it in their mouth and chew on that and spit it out. They'll be covered in blood and feces, and then they will come back and hold their children, and the children don't get sick. It's hard because, again, you don't want to feed into the hype of this. But when you look at it, their diversity of their microbiome, the average Westerner or American citizen has around 300 to 500 species of bacteria. One species could have hundreds of millions of individuals in it, but my point here is you only have about 300 to 500. The Hadza have over 1,000 different species of bacteria, over double. And it's also all over their bodies. And so what we're finding is that the microbiome is not important in pretty much every single aspect of your life that you can imagine, including resiliency and resistance to infections and different things of that nature. And so when we say like it all starts with diet, it really does all likely start with diet. And figuring out how to optimize your health around that is one of the best things or most important things we can be doing. But that's hard. That's a really hard problem to solve. I don't want to make it seem like, oh yeah, we can easily figure out all the bacteria and everything. But when people have, like autoimmune diseases like you have, when people have these types of things, those are real serious problems. And so to figure out what to do around that, obviously is very individual, but at the same time, starting with the diet is still likely the best place to begin. If it doesn't work, and if we do need to go to immunotherapies or an asthma medication in your instance, that's awesome. That's cool. That's where we've done cool science and we've figured out another solution to a problem. But at the same time, it's like, it should start with diet.
For sure. Okay, cool. Yeah, no, I always fascinated by that kind of stuff because now we have biologics and all sorts of crazy ways to solve some of these things, but I also understand people have practicality and sustainability and like what they want to live with and versus the indulgences. Even things like alcohol, I'm always having conversations with clients who rationalize the heck out of it, but still at the end of the day, they're like, I choose to imbibe a few times a week because there's for whatever reason I get enjoyment out of it and I'm going to do it. So it's always interesting from a practical standpoint. All right. Do you want to talk about training?
Sure. Yeah.
So we got a lot of lifters in our community. We talk about adaptation, muscular adaptations to training. And I think obviously the anatomy is huge here when we talk about the musculoskeletal system. So get out of the gut now and over to the other parts of the body. I think the gut may still come in here. Where do we even start here? So strength and hypertrophy are goals for a lot of individuals. We understand a lot of what it takes to go from A to B, even though I know the research is still out on all the mechanisms underneath. So why don't we start with hypertrophy, because that's the most talked about one, and the influence of training variables on muscle adaptation for that in the context of anatomy. And I'm just curious to hear kind of your unique take beyond what we hear every day in the fitness industry.
So the way I like to approach strength versus hypertrophy from an anatomical perspective is you really have to think about it from the body's perspective. So the body has no idea. So think about it like a baby is born, has no idea what environment is going to be there, what demands are going to be placed on it. And so obviously genetics play a massive role, right? You look at the body form, say, of an individual from Kenya, that's going to be different than, say, someone from Serbia. Obviously, there's going to be differences there. But at the same time, there is still this blank slate, even with muscle physiology. And so the thing I like to bring to a lot of people's attention are satellite cells. Satellite cells are a type of stem cell that exist on the periphery of muscle cells, of skeletal muscle cells. And they're waiting for a sign or a physical signal, a stress signal to tell them what to be and how to be. And there's a little bit, they can even switch fiber types, right? If we're talking about fast twitch versus slow twitch, there's little nuances with that. But at the end of the day, it really kind of just depends on the demands of your environment and what that's going to do to the actual cells waiting. And what's cool is once they say, like, if we're going to be hypertrophic, right? When you become hypertrophic, you need multiple nuclei to actually fuel that cell, because the cell gets so big that you don't need all these nuclei to be like, oh, I got to regulate this, I got to regulate that, I got to regulate this. So what'll happen is as you become hypertrophic, you take satellite cells, merge them into pre-existing skeletal muscle cells, it grows bigger, and now you have more nuclei. But then let's say you get injured. You get injured and you need to rest. Obviously, your hypertrophy goes down, but the nuclei stay. And when the nuclei stay, that makes it actually easier to bounce back and rebound. And you see this all the time in resistance training, is that people are like, oh, it was harder for me to get the gains in the beginning. It's easier to get them again, after time. And that's because you actually retained the nuclei, and that likely plays a role in helping you become hypertrophic faster. Every single time I dive deep into the literature around hypertrophy and strength and just like the nuances, there's still so much to learn. There is still so much to learn there. And a lot of times it's hard for me to even say, like, I feel comfortable saying this versus that, because there's so much that we just don't know at that granular level. Fortunately, we know enough at the macro level. It's just like, oh no, like, like these are the sets, these are the reps you're going to do, this is the weights. We know enough at the practical sense that I think it helps. But at the physiological micro sense, there's still a ton of mystery as to what's actually going on.
Yeah, really cool. All right. So there's definitely some things I want to get into here. One thing is there is a high variability of individual response. We've seen that even when in a lab setting, there are trainers telling you exactly how to train and how to be intense and execute properly, right? Because sometimes you could just say it's poor form, poor execution, not enough intensity. But even the training variables may have to change from one person to another, like which things you progress and what rep ranges you work in. And so there's a lot of variability. So that's a lot of trial and error. But what causes that variability in response when it comes to the anatomy and to the kind of the recovery and the adaptation process? I know it's a big question.
Great. No, it's a great question. So here's a good way to think about it. When I teach anatomy in the classroom, or if anyone looks at a video about anatomy, you are looking at the average of averages. right? So it's like there's certain things that we can pretty much guarantee are going to be pretty consistent, right? You have 4 arms, you have 5 fingers on 2 hands, right? There's certain things that are just pretty consistent. But when you start zooming in and zooming in and zooming in, you're going to see a whole lot of variability. So a real easy example I like to give, there are 16 anatomically correct positions for your gallbladder. Right? Now, the gallbladder, we teach, sits underneath the liver on the right side. Those 16 subtle variations are just like, they're kind of just moving a little bit. It's not like it's huge. It's not like your gallbladder's in your foot. But the point I'm trying to make here is when you start looking at the body and individual differences, you'd be amazed at how different we are, or you may be, from that generalized plan that we teach to any kind of anatomy 101 type course. And so when it comes to muscle physiology, one thing you have to think about is the different amount of neurons, the different amount of synapses, right? So like motor units, for example, right? So a motor unit is one neuron and how many muscle cells it's attached to. There are averages, right? And it also depends on the muscle group. So for instance, I think like in gastroc, so gastrocnemius in your calves, one neuron, I think, goes to about 1,600 different muscle cells, muscle fibers. So that means if that one neuron fires, all 1,600 of gastroc's fibers fire at the same time. But that's the average, right? So if I were to say, I look at your calves, we measure it to my calves, mine might be much smaller. My motor unit would be smaller. Yours might be larger. And that can actually make a difference in terms of power, right? So for instance, gastroc, you don't need to have it too small because gastroc just really needs to push off the ground. That's all it really needs to be able to do. But that means, though, for certain people, especially what's interesting when you look at the differences in elite athletes, what I love to tell people is it's like, what's the difference between first and second place at the Olympics? The 10th of a second, right? You know, they do the same training, they put all this kind of stuff. So then you know for a fact, then why, again, if we look, say, Michael Phelps, why is he so different? We've looked and done tests on Michael Phelps, and as we have on many of these elite athletes, and you see that they genetically, they have just different amounts of motor units. They have different amounts of fast twitch versus slow twitch. There's all these variabilities, and we don't know exactly why they always distribute the way they do. Obviously, genetics plays a role. Sometimes the environment can even shift that in certain circumstances. But to say like, what is it? It's what's going on. Why is this person different than this person? It's really just nature experimenting, because it's like as nature is just kind of throwing out, and there's little variabilities in the DNA. And if that's successful, then they're likely to pass on their genes. And then that just keeps on going and going and going. And so it's really just nature experimenting. I know that's not a really satisfying answer as to what makes these individual differences, but it's really fascinating to see, especially someone who's looked in the body. When I perform a dissection, you'll see so many differences. You're just like, whoa, that lung looks weird. You know what I mean? That in a respectful sense, but you're like, you'd be blown away with how different everybody is from that generalized blueprint. And so when it comes to athletics and fitness in the micro scale, those differences can really start to show up.
I love this stuff. I mean, that what you're describing is like the anatomy is the microcosm of the bigger differences we all see between humans. Like we know we're different, and you're right. It's like evolution constantly happening, even though we don't realize that's the case. And partly because humans all spread their genes nowadays, right? Like we could all survive given modern technology. I want to recap a few things just for the listener I find fascinating. You talked about how there are, multiple nuclei to fuel muscle cell, and then it draws in the satellite cells so it can grow bigger, and then they stay there, which explains why if you're detrained and then years later you get back into it, and I've seen this with clients who are detrained, I'm like, wow, they're super responsive when they come back. It's a great reason to like start today building muscle because it's going to benefit you for the long run, no matter what age you are. Also, the fact that the individual responses are so different with motor units and fast and slow twitch fibers, for example, that would explain some of the differences with like power and vertical jump capability with athletes. We also have different limb lengths, different proportions that affect your movement patterns, like with your squat and stuff like that. So just the big message is everyone's different, and you've got to find what works for you. You've got to experiment and kind of use the general guidance that we talk about, but then immediately collect data that shows you whether that guidance is kind of on the norm or is on the outliers of that bell curve.
And I'm sorry, I don't mean to interrupt you, but you actually reminded me of one more thing that I think your listeners would really enjoy. One of my favorite things to do when I would show people this in the lab is, so again, if we think about that generalized blueprint, and if you're ever teaching skeletal muscle anatomy, we always talk about origins versus insertions. So basically, it's just what parts of the bones do the muscles attach to? So when I'm teaching it in the classroom, I always teach it the same, but it's not always the same in reality. And so I want you to think about this from a mechanical standpoint. If a muscle attaches on a bone, maybe even a centimeter different from where it should, I say should in quotation marks, the average is, what kind of effect is that going to have on leverage? So you can see this, like one of my favorite examples is latissimus dorsi. So a latissimus dorsi is the broad muscle on your back. Well, for most of the human population, it doesn't touch the scapula. It goes right underneath the inferior angle. But for some people, it goes on top. And it actually covers the inferior angle of the scapula. So then what you can do is start thinking, well, what would that do to the scapula? The scapula would then be more strongly anchored to your torso. What would that mean? Well, for certain activities, you're going to be limited, right? So maybe rock climbing would not be your best because then you're going to have some kind of limited range of motion, but at the same time, you're going to be more stable. So maybe gymnastics might actually be better for someone like that. What's fascinating is, and again, there's not really easy tests for this to figure out where your muscle differences or abnormalities are, but you're likely amazing and perfectly fit for some activity. You're generally good at all these different ones, but who knows, you might be the world's best ping pong player and just never know it. Like, who knows, your muscles might literally be formed for one specific activity, and you could be an elite athlete in that if you were able to train from that from an early age. It's just a really interesting thing to think about, that muscles, literally, if they attach just slightly differently, you want to talk about the effect on a vertical. I mean, that can be profound if gastroc and soleus are attached to calcaneus in a subtly different way. And then you pack in some different fast twitch fibers. All of a sudden, you can see, Bronny James, who just recently had like a 40 and a half inch vertical. It's amazing. You can start to see subtleties really show up.
Yeah, we see that as well with both bodybuilding and powerlifting. And powerlifting with the leverages, you might have a much better squat than a deadlift or vice versa because of some of those insertions, or you see that with the bench press as well. And then in bodybuilding, it affects your symmetry and your look, oftentimes like the peak of your bicep and things like that, whether it's closer or farther away. So not that you could do anything about it, but it's good to know what they are and then maybe try a bunch of different sports and a bunch of different things to see if, all of a sudden you're really good at this. Let's talk about bone health too, because it often gets lost in the discussion when we talk about training and strength. I work with a lot of women, and obviously osteopenia and osteoporosis are big concerns. And, for me, the top thing I recommend is strength training, right? Because of the actual changes to your bone structure that get induced. So tell us about that. What have you seen? Like maybe in cadavers, we see a different intensity from a lifetime of lifting versus being sedentary or things like that.
So unfortunately, with how the body donor industry works is that if you are basically under the age of 55 and you pass away, you are likely to have your organs harvested, even if you were signed up to donate your body, because you're young enough, your organs are still likely healthy enough that they could save a life. So what that means is for body donors, we really don't see them until they're at the end of their life. So we're talking 60, 70, 80, 90, even 100 years old. So obviously you're looking at individuals who are far past optimal health. There's only been a few instances where you'll see a younger individual. It's really special circumstances. I didn't get to see it, but at the local University of Utah, I'm in Utah right now. A few years ago, they did have a bodybuilder. I didn't get to see the individual, and it's like, I really wish I could go seen that. But the stories I've heard were incredible to look at because we're all so used to seeing a 75-year-old, who had cancer. Their body is just riddled in atrophy and disease. So it's hard to actually be able to tell. In fact, it's not that I say you couldn't, but we also don't get a medical history on the individual. So I don't know what's going on. And there's this level of guesswork with it. But at the end of the day, you can still tell when people are more active than not. Right. So you can definitely tell when people are just outright sedentary. You can see it because the bones will literally shape to whatever form. So if they're hunched over, right, if they're sitting in a wheelchair or a lazy boy, or if they're laying in bed, you can see those impacts on the joints or how it impacts the joints. And you can see when people obviously just their posture, especially like if we make not to be too graphic, but if we make a cut right down the middle of the body. It's called a sagittal cut. What you can do is you can see the inside of the entire vertebral column. And when you see that, you can see postural shifts, postural changes, but you can also see the density of what we call spongy bone and how thick the little arches are inside of that. And so the thicker they are, this is almost always true, the thicker they are, the healthier the bone. There are some differences, but the point I'm trying to make here is I can often tell, like, oh, this person was 80. Yes, they died of cancer, but they were actually pretty active. This other individual, you can see just the thinning of the bone, and you can tell, okay, they were likely unactive. And you can also see their bones are just literally shaped differently based on how they were sitting. So unfortunately, you can't look at someone and say, oh, they lifted weights or anything like that. Just at that age, it doesn't work as I wish. But unfortunately, it's more of a guessing game at that point.
Yeah, I guess we have to settle for DEXA scans and stuff of living people. We do see that. I was just curious. But the logic holds then if you see the bones getting more brittle and spongy due to lack of activity and simply walking and holding up your normal frame that does load your musculoskeletal system regardless, keeps them from doing that. It goes to reason that adding more load would make them more dense and strong, which, we know from living people, but I was just curious on the cadaver side. Okay, so that addresses activity. What about neurological adaptations to training? Is there an aspect of anatomy where we're able to see that, given that it's in the brain, but I assume it's also tied up with the nervous system in some physical way? I don't know.
So there's nothing you can really see with the naked eye. If you're looking at, say, like slides, if you're looking at some kind of like micrograph or something, you're going to be able to see just how the nervous system does adapt. And the nervous system adapts in some really cool ways. I think a lot of people are understanding of the plasticity of the brain and how neurons can actually move around there. But there's also some plasticity at the actual neuromuscular junction. There's some plasticity as it works with what's called the fascial system. So, and how that is all innervated. But it's hard you can't really see that with the naked eye. And so for me, in my experience, I've worked in what are called gross anatomy labs. So a gross anatomy lab is just what you see with the naked eye. So we were never using like a microscope or anything along those lines. So I don't have a lot of experience myself in really analyzing the plasticity at a practical level, but I can tell you intellectually and what I've read in the research is that you do see that. Obviously, if you are prioritizing a specific workout, a specific lift, so, I mean, like for instance, say like you're a rower, you are a competitive rower, say in college or something. Well, obviously your nervous system is going to adapt not just in your actual brain, but at the level of the muscles, right? At the joints. You're going to see plasticity around the actual neurons inside the joints. This is something I don't think a lot of people understand because they're called like joint kinesthetic receptors. You have receptors that monitor the positions of the joints. Those can become more finely attuned. And so they can actually send feedback to the brain quicker and more efficiently so that you can get better response time and reactionary time. So those types of things we know about. We see that in the literature. It's something you can train for to some aspect, but it's not as simple as like, oh, I'm just going to do this one activity and then I'll become superhuman at it. Obviously, there's limitations to it, but at the same time, the body definitely does adapt at that neuromuscular level.
That's amazing, man. This is one of the coolest interviews I've ever had, Justin, because you're coming with like unique things that people don't think a lot about. And I just learned something. I didn't even know there was those kinds of neurons inside the joints. You said they were joint kinesthetic receptors, and it kind of makes sense. We use the terms muscle memory and all of these things. And I'm assuming that's what we're talking about when we develop a pattern and we repeat that pattern and then it gets reinforced to the point where it's almost automatic. And you're right, like the reaction time picks up as a result. And the fascial system as well. How does that come into play? The fascial system, I'm familiar with that somewhat with like massage, for example, and injury rehab.
So fascia is one of the most misunderstood layers of the body. And so historically speaking, from an anatomist perspective, fascia was the thing you removed to get to what's interesting. So for people to understand this, you were to remove the skin. Before you get to the muscle, there's this connective tissue layer that goes on top of the muscles. That's what we call the fascia. So fascia, since it's been largely ignored, there has not been a lot of research. And even today, it's controversial. What you'll see is people in the massage realm, right? So chiropractics, massage, physical therapy, even will get in there. A lot of them are real big fans of fascia. But then if you look at, say, like classical anatomists who are more academic anatomists, they're still kind of like, it's not that big of a deal. In terms of like you can definitely have fascial issues, but in terms of like boosting performance dramatically, a lot of people are skeptical. And I've looked at the data on all sides, and it's hard to really make up my own mind on where I sit with it. But the thing is, fascia is very richly innervated. So it's not just this connective tissue layer. There are plenty of neurons in there. And what they're doing is they're sending feedback to the brain about the position of muscles, the overall tightness. Because you have to think about like this. If you say like on your arm, so the arm, fascia wraps the muscles of your arm and creates what's called a compartment. And that compartment is pressurized. If you actually cut the fascia, that reduces the efficiency of the muscles inside of that compartment by as much as 15%. So what that also means is, let's say like, well, what impact then does hypertrophy have on the fascia? These are active and open questions that people are looking at to see how that can be reflected inside of performance. And we just unfortunately don't have a lot of answers around it because it's been ignored for so long. The data we do have, and I say this with respect, comes from people that are highly biased, right? Like the fascial research comes from the Fascial Research Society or things like that, where not to say that it's outright wrong, but at the same time, it's like we need more data before we can really understand what's going on. So it's hard to really talk about fascia outside of the hype. Just understand there's a lot of active research going into fascia because there does look to be some exciting stuff.
Okay, yeah. I mentioned the massage therapist because I try to get one every month, and she's like, yeah, she'll mention it. And again, I've heard it in the physical therapy realm, but it is pretty cool that there are obvious mechanistic and physical interactions that we can prove with, like you said, if you cut it or something. And so then what's the reverse on that in terms of how we can impact it? Very cool questions. Lots of excellent questions. I guess the last thing here, is there anything you wish I had asked you related to personalizing your training and nutrition around anatomy?
That's a really good question. I don't know. I think we got around. I thought we did pretty well today. I don't know that there's anything that just jumps to my mind. I think what I would like to tell people is that anatomy is oftentimes a boring science. And I say that as someone who loves it because anatomy is a science of just classification. It's just like, here's, this is your flexor carpi radialis, and it attaches here. That's a pretty boring thing, but the power that comes from it, especially for those who are really interested in their body, you can't oversell it. It's an amazing science that I encourage everyone to look into. And there's plenty of fantastic resources online for it. But in terms of like questions that I think we covered pretty much everything generally speaking, everything that I would have liked to.
Yeah, no, it's awesome. I didn't know some of the things we uncovered. It's going to get me to want to look more into anatomy in my practice and for the podcast as well. And I'll probably hit you up on like some of these really good resources besides you, which you're an amazing resource, of course, for folks, because I think we take, we take too much of an anecdotal approach sometimes. And some of these big questions are being answered out there. And we just need to start merging the different disciplines even more powerfully. So where, Justin, can people learn more about you and your work?
Yeah. So like you mentioned, the Dissection Room is what I'm doing. There's a YouTube channel called The Dissection Room. You can find me on Instagram. I think my Instagram handle is Real Justin Cottle. Just, you can send me DMs and everything going there. Substack, The Dissection Room. Those are the places to find me these days.
Cool. Yeah. And guys, check out his YouTube channel because it's super highly produced for one. So kudos on like the production quality. But the topics are they're legion. I mean, they're across the board. If you're just into geeking out on anything, whether it's technology or philosophy or whatever, he's probably got it covered in there. A very long library of really cool stuff, especially a lot in the health realm as well because of the anatomy angle. Thanks again, man. Justin, this has been a lot of fun. We learned a lot. The listener learned a lot. And it was a pleasure having you on.
Thanks, Philip. I appreciate it.
Thank you for tuning in to another episode of Wits and Weights. If you found value in today's episode and know someone else who's looking to level up their wits or weights, please take a moment to share this episode with them. And make sure to hit the follow button in your podcast platform right now to catch the next episode. Until then, stay strong. Hey, before you go, I want to let you know about a free resource I have. They are free guides on everything from fat loss to eating out to building muscle to managing hunger to figuring out the best macros for you and more being added all the time. You want to get the most out of these podcasts and your time to look and feel your best, and these free guides will give you a quick and easy way to know what to do. If you want to get your hands on these completely free guides, you can head over to witsandweights.com/free. That's witsandweights.com/free to get your free guides and level up your results today.